Morning. Again, good morning, grade 7. We are still in the integrated science process skills. Okay. Again, the integrated science process skills was actually developed because of the basic science process skills. What are those basic science process skills? Name one. What are those? The basic science process skills we have.
Is it logical reasoning or thinking?
Logical reasoning, yes. What else? What are others? What are the other science process skills? Basic. We have, it's in the screen. Observing. Okay. These are basics.
Is measurement like in?
Yes. Inferring. Okay. Inferring is actually goes hand in hand with observing. When you observe, you infer.
Communication.
Communicating.
Communicating, yes. Classifying and using of number relation. Those are basics, right? Again,
Inference.
these are patterned, or the integrated science process skills are patterned based on the basic science process skills, right? What are the integrated science process skills we have? Anybody?
Isn't it already in the chat?
Let me check. Yeah, these are the basic.
Yes.
Okay. Let's have the integrated science process skills. We have
Defining operationality.
operationality, correct. What else? You know what? I really like this class. Why? You cooperate. You participate. Okay? That's good. That's good to hear. Especially Travis. And the rest. Jairus also. Sebastian also.
Induction.
What else?
Induction.
What else? We are done with operationality. We're defining operationality or operationally. What else? Identifying and controlling variables, because that is part of the experiment. Here we need to identify and control the variables. What are the 3 variables present in an experiment? We have constant variable. Second is what? Independent variable. Okay. The third one is the dependent variable. We'll be checking on the dependent variable for the output or the outcome of the experiment. Okay. What else? We have formulating hypothesis. This is your wild guess, your educated guess with regards to your experiment alone. Okay. Interpreting data. This is analyzing the data being gathered all throughout the experiment. Okay. Experimenting, formulating a model out of your experiment. Okay. Just like what we are doing now. Okay. Your vaccines are the output of science. Your vaccines also are part of the experiment. Okay. They tend to, again, I am stressing it out, they tend to get a spike protein from the virus itself. So like, for example, if you're going to look at the virus, it has a lot of spikes in their outer shell. Okay. Those spikes contains mRNA, which enables the virus to go into the cell. Okay. It looks like a key going into the cell. So again, this is part of the experimentation. They tend to remove one, isolate it, and they create vaccines out of it. Now they're creating model. Okay, they're creating model of the vaccines. Like for example, AstraZeneca. What else? Pfizer. Those are their models. Okay. Let's move now to scientific method. You will be using all of those, the integrated science process skills and the basic science process skills in the scientific method. So this is the main lesson of the integrated science process skills. This is now the application. Okay. The scientific method is a logical and rational or rational order of steps of answering questions about the world around us. Okay. There are a lot of questions in our mind that the logical way of answering them is through the scientific method. Again, do not believe in something that there is no logical reason behind or there is no
And
scientific
like there
reasons
is
behind.
no proof. No proof.
Correct. Okay. That is why until now, scientists still doing the scientific method, even until now. Okay. It relies upon the data and involves four key processes. Okay, number one is making observations. Okay, again, making observations. That's the first one in the scientific method. The problem may arise in the making of the observation. Okay, sure. I thought scientific method starts with a problem, statement of the problem. Yes, the statement of the problem started in the making of observations. When you observe, you generate a question in your mind. That is now the statement of the problem. Okay, formulating hypothesis. This is your educated guess. Okay, you are now thinking about answers or logical answers to the question arise from the observations. Okay, that is your formulating hypothesis. Okay, doing an experiment. The third one is the attempt. Okay, to prove that your hypothesis is correct. Okay, experimentation is the attempt not to prove that your hypothesis is correct, right? And drawing out a conclusion. Okay, in drawing out a conclusion, you now conclude based on your research and based on the result of your experiment that your experiment is true, and this is what you had find out. How many times can a virus mutate? A lot of times. It depends upon the situation. It depends upon the environment. That's the environmental factor. Like for example, heat. Okay, remember that August is in Chinese. It's ghost month, right? And because of that, there is a shipment or there is a transition between hot to cold. Remember the Burr months? It is the cold months. So because there is a sudden shift of from hot to cold, tendency is the mutation is faster. Okay. Let's move forward. Let's have the making of observations. Okay. All scientific studies begin with observations. Yes, they tend to observe. Like for example, if I have it here, can you see it clear? Okay. I will just remove first I will remove it first, my background, in order for you to see it clearly. Okay. Can you see it clearly now? Okay. If I have something here, what can you observe on the specimens presented to you now?
What is that yellow stuff?
Okay, what is that yellow stuff? That's making observation. Yes. Any other observation? The yellow stuff is called formaldehyde. It is actually a composition of 30% formaldehyde and 70% water. 70-30. No, 60-40.
It looks
60%
like
water,
a
40%
the stuff inside it looks
formaldehyde.
like kanang a box. Like kanang
Box?
squeeze ng a box.
It doesn't actually contain a box.
Is it any organ?
Yes, this is an organ, correct?
Kidney?
Heart?
This is a heart, correct?
Oh,
So again, this is now making observations. Okay? You are now creating observations out of your mind on the object
Sir, what
presented.
is that a model or that's actually a heart?
This is the actual heart.
where did you get it?
Okay, my class before, we did dissection, heart dissection. So this is their output. Okay? So that is actually one way in making observations. You tend to observe what's the fluid behind, what is it inside, and all of those. Oh, all scientific studies begin with observations. Observations are done using your senses, your sense of touch, your sense of smell, all of your senses. When you observe, you recognize some properties like color, odor, shape, and texture. Okay? The data gathered through the senses, or if you gather data through senses, it is called or referred to as qualitative data. Okay? It's qualitative data. Sometimes when observing, you make use of tools like ruler, spring balance, thermometer for temperature, and the graduated cylinder. Okay? The data gathered using the tools or using these tools are called the quantitative data. Okay, again, if it is in your senses like what you are doing just a while ago, it is called qualitative data. Okay, qualitative observation. You observe the color, you observe the shape, and all of those. So those are qualitative data. But if you're now using graduated cylinders or thermometer for the temperature, in the spring balance or the ruler, you're now gathering what? Quantitative data. Okay? Observations, however, do not need to be direct. Like for example, the atomic nuclei and magnetism cannot be perceived directly through the sense organs, but their effects on other objects can be observed directly. Okay? It, it cannot be actually, sometimes we cannot observe it directly. That's indirect. We can observe their effect on the other thing, okay? But you're using your senses, okay? But their effects on the other object can be observed directly, okay? Most of the time, you make an inference using an observation, correct? What is then an inference, okay? An inference is a statement of an idea from an observation. This is the basis for making a model, your inference, okay? A model is used to visually explain something that is not easily seen or understood. Okay, like for example, a plum pudding model of J.J. Thomson. Okay, that's higher already. So J.J. Thomson explained that the position of the electrons in an element is scattered like a plum pudding model, like a plum pudding. It looks like a bread dough that a lot of electrons are actually scattered in the surface. So that is
Teacher,
the
I have a
model.
question.
Yes, Travis.
Is the kanang diba, an atom is one thing, but inside it is the protons, and inside the protons is neutrons, and inside the neutrons is electrons, right?
Actually, it's inside an atom. An atom composed or are composed of protons, neutrons, and electrons. Okay, they are actually different, Travis. So if you're going to look at an element or an atom, okay, it can be subdivided into three: protons, neutrons, and electrons. When you say protons, it is positively charged. Okay, since it is positively charged, it easily be attracted, or the electrons can be easily attracted to protons. So the protons there is in the center or the central nucleus of an element or an atom. Okay. Now the electrons is scattered in the environment of the protons because they are what? Attracted to it. Remember, positive and negatively charged attracts. Okay. And then neutrons are the neutral element. Okay. These are neutral atoms, or these are neutral element in an atom. Okay. That's the proton, neutrons, and electrons. Okay. They are actually separate.
So like what you're saying is if a I mean if positive and positive it doesn't like attract each other, so it's like a magnet, right?
Yes.
Okay.
Opposite attracts. Okay. So again, a model is used to visually explain what something that is not easily seen or understood. So that's the reason why we need to use models. Okay. Observations may lead to questions that could become the topic of the scientific study. In the other words, you can ask question about your observation you made. So just like what you are doing a while ago. Okay. You're actually asking questions. And because of that, the science, what is this? I forgot. Okay. And because of that, you are now, because of your observation, you are now creating questions in your mind. Okay. That's actually leading towards your question or the statement of the problem. After making a question, try to find what is already known about the question. Okay. Your background knowledge about the question. You may search across different sources like journals or papers written by scientists. You may also ask resource person or use the internet if in case. Let's move now to formulating hypothesis. Okay. Talking about formulating hypothesis, there are a lot of way on how to formulate your hypothesis. Okay. This is actually based on the question that is in your mind, okay, during the observation. Okay. Once a question has been stated, a scientist formulates a possible answer to the question. That's your educated guess. Okay. You are now trying to answer the question that is in your mind. Okay. The possible answer to your question is called hypothesis. That's the educated guess or uneducated guess. It requires careful thinking and application of skills. It will not stop there. Hypothesis will not stop there because you will be testing your hypothesis through an experiment. Okay. Doing an experiment to test a hypothesis, a scientist performs an experiment. Yes, an experiment is a controlled procedure that confirms or rejects your hypothesis. Okay. In science, an experiment usually involves an experimental setup and a control setup. Okay. The experimental setup differs from the control setup by one variable. The factor in the hypothesis that will affect the outcome of the experiment. That's one variable. Okay. What do you think is that variable? Let's find out later. It is important to change only one variable being tested to keep other factors constant. Okay. When the experiment is completed, the experimental setup is compared with the control setup. Okay. This time, the scientist determines whether the variable that has been changed affects or does not affect the result of the experiment. Okay. There you go. We already discussed these variables. The variable being manipulated in the experiment is called independent variable because it's independent. Okay. Because it is manipulated. You are actually changing it. So it's independent. The variable measured to determine its response to the independent variable is the dependent variable. dependent variables are highly dependent with the independent variable. For the reason that results may be gathered or can be gathered in the dependent variable. That's the reason behind. Are you okay? Are we okay? Jaden? Okay,
I thought my mic was unmuted.
oh, okay. Just let me know, huh? This is the reason why you listen grade 7. This is the reason why I am chopping this one by one or little by little, because there are a lot of terminologies, and somebody suggested to make it faster, to discuss it faster. No, I cannot do that. I am adjusting it. I am adjusting the lesson towards you. But if it is me alone, I can absorb this directly because I already bumped million times with these terminologies. But some of you just bump to these terminologies. That is the reason why we're taking it little by little. Just let me know, okay? If we are too fast, right? Okay, again, there are a lot of variables to be considered in the experimental setup. We have the independent variable, which is the one being manipulated, the one being changed, the one being um the one being subject to change. Okay, sometimes they are subject to change. The variable measured to determine its response to the independent variable is the dependent variable because it is highly dependent to the independent variable or the changes. Okay, we'll be measuring the changes there. And all variables that do not change are considered as constant variable. Okay. Constant variables are important also in order for us to determine the result in the independent variable or the effect of the independent variable in the dependent variable. Okay, I will be confused. I understand. I understand. I am with you. Levi, I am with you. Okay, don't worry. Just let me know. Okay. Travis also will be helping us, and the rest of the students will be helping us also. Okay. Let's work hand in hand with this, right? Let's make it this as easy as possible. Right? It's okay, it's okay. That is why I'm discussing it little by little, because I'm with you. Okay? I'm always with you. Okay? The terms being used there are already simplified. I already stated this in the lowest term. Okay. Manipulated or changed, huh? So independent variable, these are the variables being changed. Manipulated, giusab. Okay. The variable measured to determine the response to the changes that we had made is the dependent variable. Okay. And the variables that do not change at all or remain constant is the constant variable. Okay. Do you have any question? Okay.
No, sir.
Let's move forward. It is only by carrying out a fair tests that you can be sure that what you have changed or the independent variable has affected what you measured or the dependent variable. Okay. Again, we'll be measuring the dependent variable, right? And we'll be changing the independent variable. You conduct a fair tests, okay? If you change only one factor at a time while keeping all conditions the same, okay? Let's tackle later fair tests, okay? We are done with experimentation. That's testing your hypothesis. We are now down to drawing a conclusion, okay? A conclusion is based on the interpretation of data gathered, okay? You cannot actually conclude unless you have interpretation of data gathered, okay? Because this is based on facts, based on the gathered data. from the experiment, right? The data may or may not support your hypothesis, okay? It may accept or may reject your hypothesis, right? Hypothesis, SIS is singular. Hypothesis, SES is plural.
So I spelled it right.
Yes.
Yay.
If then data do not support the hypothesis, scientists may try the experiment again or plan another one or a new one. Okay? If the results still do not support the hypothesis, scientists may form another hypothesis. Okay? Scientists may form another hypothesis. Failure to come up with the supporting data is not a waste of time. Okay? New information and procedures can be gained in the process. This is the reason why in the laboratory we are testing our hypothesis a lot of times. Okay? Some of my students burned out because of this. Okay? But the learning is there. They learned something out of their experiment. Okay? We have done a lot of experiments, including experiments that that enables them to discover something which was quite very intriguing. Okay, let's move forward. If data support the hypothesis, scientists repeat the experiment. Okay, if a number of similar experiments yield the same results, scientists will publish a paper and share the information with other scientists. Okay, there is now reporting. Okay, they tend to publish it, right? A hypothesis that has been tested and consistently supported by data becomes a theory or theoretical.
Is a theory ka ng or siya ka ng, it's similar to like a rumor or like something. Wait, it's kind of hard to explain. A rumor is something like more siya, something not real.
Okay.
Is it something like that? Yeah, not true. But it's like
in
opinion.
in scientific world, theory, we're using theory to explain, okay, to explain something or based on our observations during the experiment. That's a theory, theoretical. Okay, gossips are different because there is no basis for gossips. Okay, there's no basis for gossips. Theory has a basis. Okay, based on the repeated observations and even experiments. Okay, again, a theory is an explanation based on many repeated observation, okay, during experiments. It helps explain the behavior of objects or events in nature. Like for example, what is the theory of, okay, this is a challenge for you. What is the theory of Sir Isaac Newton?
A what?
The theory of Sir Isaac Newton. Newton's theory. Newton is thinking about an object, the falling object. Okay, it
Doesn't
started
this
with
something have to do with calculus?
the theory. Okay, it started with the theory and now become a law or became a law. Okay, the theory started by Isaac Newton. These are the theory of what? There's something to do with the gravity. Okay. The theory of first one is the inertia, but now becomes a law of inertia. The second is law of the theory of interaction becomes the law of interaction. The third theory of Sir Isaac Newton is the law of acceleration. Okay, it's under physics, correct? Okay, it became now a law. Those are theory. Okay, that became now a law. So it started with inertia. An object at rest remains at rest. An object in motion remains in motion unless acted by the unbalanced force, which is true. And we actually tested that one. And it gives us impression that it is really true. Okay. Law of interaction. In every action, there's always equal or opposite reaction. It's true also. Okay, it's true. Even riding a car, okay, it will give you an explanation. So those are few of the theory. Einstein also has a theory. It is called the theory of relativity. Okay, that space and time is relative. So those are theory. Okay, it helps explain the behavior of object or events in nature. Okay, a theory is not permanent, just like what Sir Isaac Newton did. It's not permanent. It may be discarded as new information is obtained. Okay. Often, patterns are observed in nature. Okay. A general statement that describes patterns are called scientific laws. We have actually scientific laws. Okay. A law summarizes a natural occurrence that may consistently observe under the same condition. Like for example, the lunar eclipse. It has scientific laws. Okay. What else? The solar eclipse. It has scientific laws already. Okay. We cannot just tell ourselves or tell our neighbors that, oh, kanon ka sa bakunawa, because it is already explained in science. That's the reason behind. Okay. What else? La Nina, El Nino, those phenomena are explained by scientific laws. Even high tides and low tides, those are explained by scientific laws. Okay. It may be expressed in words or mathematical form. Okay. It is already time, I think. We still have 4 minutes left, but I think we have touched or tackled much already, right? I don't want you to have an information overload. If you have question, please raise it in our GC. You can directly ask to me, or you can raise it in our GC. Okay, in order for us to have a discussion, right? Do you have any question, Mariana? Yes.
Sir, I have a question about computer. I'm not sure where to submit the video.
Okay, for the video, I will just yeah, I read some of the comments of your classmates, your conversation in our GC. Your video will be submitted in your LMS. I will just let you know.
Wait,
Okay.
sir, I also have another question.
Yes, Travis.
How do you make the the Windows generation thing?
How do you make? Okay, in a video form. Okay,
How
you need to
exactly? Like
do it in the video
Excel?
form. You try downloading different editors. Okay.
Filmora.
Yeah, those. Filmora, what else? There are a lot of editors. Adobe
Have hack.
Premiere
I can
Pro.
send. I can send kanang the crack version of Filmora and give the link to everyone.
Oh,
So
please,
there will be
please,
no watermark.
please give
Yeah, I
it to your
will.
classmate also. Okay. So Travis has installers or installer for Filmora. It's a good editor
Crack.
actually. Okay.
No payment.
Then all you have to do is to have the videos being compiled, number one. Number two, with your own creativity, how would you introduce those in a video form? At the same time, remember to have also a narration, okay, a discussion from this version to the other version, and include Windows 11. Okay, Windows 11 is not yet in the market, but they're planning to release it in the middle of this year. Okay, at least we will have something in our mind about Windows 11. Although I started already installing Windows 11, but I uninstalled it, right? Because it is still in the process of engineering. It is not the actual OS. It is actually a prototype. Any other question? Question? When do we pass? Okay, at the end of the first quarter, before the exam. Okay, that's the deadline.
You can still pass it early.
You can pass it early. Okay, I will just create a link in your LMS in order for you to drop by your videos, right? But do not be in a hurry. Do not be in a hurry. Take time. You gather all the data. You gather all the videos that you want, and use the editor that Travis actually suggested. The
I'll
Filmora.
still
It's a good
send I'll still
Filmora.
send the link and how to like make it cracked, because it's you need to do it manually, but it doesn't really take that much time.
That's good. Okay, do you have any questions so far? Okay. I think we discussed much. If you have questions, please raise it in our GC again or ask question directly to me, right? I think that'll do it for today, class. Have a nice day, grade 7. Thank you for participating. Enjoy your day. Have a nice day.